So we're going to solve trigonometric equations, and it's going to involve some of the work we did in the last section, which was to work with the inverse function. We'll start out with kind of a nice friendly one, a simple one. 1 minus cosine of theta equals 1/2. And now, typically speaking, we're going to solve these for a certain interval. And that interval is going to be 0 is less than or equal to theta is less than 2 pi. And I'll put less than or equal to 2 pi. A lot of times it's just less than 2 pi. So we want to get theta by itself. Well, a good way to start would be to subtract 1 and get minus cosine of theta equals minus 1/2. Then what? Well, we can divide by -1, get rid of that negative. Cosine of theta equals 1/2. But now I want theta by itself. So if you wanted to finish solving this for theta, you could rewrite this. Can anyone tell me what theta would equal? Theta equals, not cosine. There you go, inverse cosine of 1/2. Basically, it's the angle whose cosine is 1/2. So these two things are equivalent. I could write this one or this one. It doesn't matter which one I choose. Either way, it represents the same thing. Now here's where you want to keep something in mind about math problems. Usually, we don't waste words. If there's something in the problem, then you want to pay attention to it. And the thing that we want to pay attention to is this right here. We want all the solutions in the range of 0 to 2 pi. Well, what do I know? I know that the x-coordinate of this angle is 1/2. So let's just do that here. That's 1/2. And let's kind of sketch that into our graph. So here, and let's see, I want to do it in something a little more contrasting. There we go. If you look, there's really 2 points on the unit circle that have an x-coordinate of 1/2, right? What are those 2 points? Where on the unit circle do you have an x-coordinate of 1/2? Well, if you're looking at that going, I don't have my unit circle, that's okay. You can take your calculator. Now, I'd suggest that you have your calculator in degree mode, because you're not going to recognize the number in radians. But if you do the inverse cosine of 0.5, 60 degrees. Oh, yeah. At pi over 3 is where you have an x-coordinate of 1/2. But where else do you have an x-coordinate of 1/2? Right down here, right? Straight angle, or straight line all the way down. 5 pi over 3. Or pi over 3. So theta is one of this set. It's either pi over 3 or 5 pi over 3. What's telling me that I should answer in radians as opposed to degrees? Yeah, because it told me to give theta between 0 and 2 pi. If I wanted the answer in degrees, I'd say between 0 and 360. So that's your clue on that one. Let's try another one kind of like that one. Any questions on problem 14 before we look at problem 16? All right. Everyone's completely satisfied. That's great. It's good for the home audience to know. Cosine of theta plus 1 equals 0. This one should actually be a little bit easier. You don't have to do too much work to solve for theta. I get cosine of theta equals -1. What's an equivalent expression to cosine of theta equals -1? Anyone? Inverse cosine of theta or theta equals inverse cosine of -1. Whoops. There was almost a typo there. Emphasis on almost. So you're looking for where the x-coordinate on the unit circle is -1. Where's that going to be? Pi, right here. So -1 and 0, and that happens at an angle of pi. So in this case, there's really only one answer, and that's pi. So those are a couple nice little warm-up examples. Let's get into it a little bit more. Let's try problem number 26. For cosine squared of theta minus 3 equals 0. What would you do to solve here? What would be the first thing? Joe, any suggestions? I want to kind of get theta by itself, but what would we start with? Or what could we start with? All right. Add 3 to both sides. I like that. So I get 4 cosine squared of theta equals 3. And let's divide both sides by 4. Cool. So I get cosine squared of theta equals 3/4. That's getting closer. Any suggestions? Yeah, go ahead. Yeah, let's take the square root on both sides. Cosine squared of theta, 3/4. So I want to take the square root on both sides. And let's see here. Let's do it this. Square root and square root. But hopefully you don't take the square root just like this. There's a little bit something else that I would expect. Ah, well done. Plus and minus. Yeah, you need to take that plus or minus, and that's going to make a little bit of a difference because that's going to give us a couple more solutions. Now, the square root of cosine squared is just cosine. Cosine of theta is going to be plus or minus the square root of 3/2. And so there's 2 possibilities we have to contend with. Cosine of theta is positive square root of 3/2, and cosine of theta is negative square root of 3/2. So let's look at both of those. We'll do that up here. Cosine of theta is the square root of 3/2. That's equivalent to what? Theta is, thank you so much, inverse cosine of square root of 3/2. So you're looking for angles whose x-coordinate is the square root of 3/2. So, yeah, it's all right. School pays for it. So, Amanda, maybe you can help us out. Do you see a couple angle whose x-coordinate is the square root of 3/2? X-coordinate. All right, good. Down here, 11 pi over 6 and pi over 6. So those 2 places have the proper x-coordinate. That'd be 2 of our answers. So pi over 6 and 11 pi over 6. Awesome. But there's another possibility. Yeah, the negative case. So cosine of theta could equal negative square root of 3/2. Flipping that around, cosine inverse of negative root 3/2 is theta. And now I've got a couple more solutions that I could use. What are my choices for theta? Brian? What angles have a cosine of negative root 3/2? So cosine would be the x-coordinate. Where is there an x-coordinate? At what angle is the x-coordinate going to be negative root 3/2? Good. Right here. 5 pi over 6 and 7 pi over 6 have the proper x-coordinate. So those are our remaining 2 solutions. 5 pi over 6 and 7 pi over 6. So altogether, 4 solutions here. And let me just list it out this way. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi. Let's see. Yeah, 11 pi over 6. There we go. So overall, that's your solution to this particular problem. Notice these are in exact numbers. You could do the inverse cosine on your calculator and you'd get one of them, but you wouldn't get both of them. In fact, even if you put your calculator in degrees, you get this one. You get 30 degrees, which is fine. You realize that 30 degrees is pi over 6. But you got to keep in mind that there's 2 angles with that same value of cosine, and you have to list them both. You know, as long as I see all 4 of them, you know, an alternative to this, you know, save yourself a little bit of time. You could circle that and that. Just as long as I see all 4 solutions, that's what I'm most concerned about. And how you list them. I mean, this curly braces stuff is really nice. That's what you use to denote a set. But I'm not really trying to be that rigorous about it. I just do this out of habit. It's not something that you have to do. In fact, the last time I taught this course, I just listed it like this. I could put an or here. So, yeah. So thank you. Thanks for the question. Let's keep going. Anything else on problem 26 before we move on to problem number 22? You're going to try problem number 22. It's going to be a little bit easier. But let me get you started. This one is 4 times the sine of theta plus 3 square roots of 3 equals 1 square root of 3. Well, we got to get sine of theta by itself to begin with. Suggestions. You know what? By the way, just to give you a little heads up. That 1 here, I kind of put that there as a reflex, thinking kind of ahead. You have to realize that 1 is there yourself, because we're going to try and get sine of theta by itself, and that's going to start by subtracting 3 root 3 from both sides. And some people might be a little bit confused by that until they realize that, oh yeah, there's just a 1 here. And now these are like terms, and you can subtract them. 4 sine of theta equals what? Thank you. Negative 2 square roots of 3. So, from here, why don't you see if you can't solve it? While you're working on that, I'm going to do one of my famous manual pause buttons. Paused. There you go. So you can fast forward until you don't see that anymore. It'll help out when you divide to put your expression in lowest terms. put it in degrees and then figure out what it needs to be in radians? So you want to cancel, right? 2 and 4 cancel, so it gives you negative root 3 over 2. Those are both right. Can't say hope like that. Oh yeah, that's quite clever. I like before waiting. All right. So the trick here is to divide both sides by 4. So I'll get sine of theta equals negative 2 root 3 over 4. But you can put that in lowest terms. That's really sine of theta is negative root 3 over 2. Or better yet, theta equals sine inverse of negative root 3 over 2. So these last two are equivalent. You can write it either way. But what you're looking for is the place on the unit circle with a y-coordinate, or an angle with a y-coordinate of negative root 3 over 2. So take out your unit circle. Y-coordinate is negative. That's going to be in quadrants 3 and 4. Negative root 3 over 2. That's this angle and this angle. Now, maybe you're just kind of like, I'm not really good with the unit circle. I don't get it. Another possibility for you is you can do this. Put your calculator in degree mode. Most people are going to be happier in degrees anyways. Let's do the inverse sine of negative square root of 3. Now you got to be careful. See that little arrow here? It's telling me that I'm still under the square root. Go to the right once, divided by 2, and I get negative 60. There's two problems with negative 60. First of all, it's in degrees. So you look at that and go, oh, well, I know that. That's really pi over 3. But there's also a problem with negative pi over 3. Negative pi over 3 is not quite the right answer for us in this case. Can anyone tell me why negative pi over 3 is not quite the right answer? Well, kind of like the first problem, we're looking for theta to be between 0 and 2 pi. And a negative angle just doesn't cut it. So you have to use the positive angle here. So instead of negative 60, it's positive 300. And 300 is really 5 pi over 3. What's the other angle that has this as a sine? 4 pi over 3. Good. And you can see both of those on your unit circle. They're ones down here with a y-coordinate of negative root 3 over 2. So 4 pi over 3 and 5 pi over 3. Doing all right on these first few? So, yes? Okay. Let's do one that's not a nice exact one, at least not one that we can get directly off our unit circle. And then we're going to have to think on it a little bit. It's problem number 48. We've actually done this one before, earlier today in section 3.2. Cosine of theta is 0.6. All right. So he's telling us we've done this one before. Okay, I believe him. Again, we want to try and find theta between 0 and 2 pi. What are our possibilities? What's another way to think of this? What's theta? Thank you. Inverse cosine of 0.6. So, all right. And let's at least work it in degrees initially. Mostly because it's tough to relate to this in radians. We'll eventually get back to working in radians. So 0.6, call it about here. There. And here. 0.6. So what this is saying is we want to find the angle, call it theta, whose y-coordinate is about 0.6. All right, so I was missed a little bit there. No big deal. If you did this off your calculator, you'd get, what? Is it 53.13? About 53.13 degrees. Great. But keep in mind, there's another one. There's another angle, except this one is down here in the fourth quadrant. Both of those angles are going to have that y-coordinate, or excuse me, that x-coordinate. So the other possibility, well, I don't want to go negative because that would be wrong. I need a positive angle, so I need to go in this direction. I need to go around that way. How could I figure out this angle except in the orange direction? Ah, good. So it's going to be 360 minus that angle. 360 minus 53.13. So on your calculator, the nice thing is you don't have to type in that number again. So you will do inverse cosine of 0.6. And then I can look at 360 minus my previous answer. So you hit the second key, and then the opposite key, types in your previous answer, and there you go. So now you've got both possibilities. You got 53 degrees and 306.87 degrees. So those would be your two answers, but that's in degrees. What would I do if I wanted this in radians? So let's do this in radians, which is really what the problem's asking you to do. The first one's going to be pretty easy. Just put your calculator in radian mode. So I'll go back to radian mode. And you can cursor up here and grab that previous calculation. Bam, there you go. 0.927, etc. And that's in radians. This is 0.92729, blah, 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 as many digits as you want. But here's the tough part. How are we going to get that other one in radians? I mean, you could take this answer and multiply by pi over 180. Not really interested in doing that. What's the radian equivalent to taking 360 minus my angle? 2 pi minus your angle. So let's do that here. Type in a 2 and then a pi. So just type it directly into your calculator. 2 pi minus this answer. And you can go up and grab that answer. You just cursor up, press enter, and then bam. You have plenty of accuracy doing it that way. So, or 2 pi minus 0.92729, etc. And that's approximately 5.3558, etc. So, a couple ways to get that one. It's whatever you're comfortable with. The important thing to see is that there's two solutions here, and I need them both. Any other thoughts on problem number 48? Yes, please. I'll probably specify radians, just because when you get to calculus, 95% of your work is going to be done in radians, because when you work in degrees, there's this ugly little constant that rears its head. So, yeah, you kind of got to used to working in radians. There will be a little bit of a break when we get to chapter 4, and we start working with the law of sines and law of cosines, and it'll be like, woohoo, degrees. It'll be great. And everyone will get an A on that test, but then it'll be back to normal for the fourth test. But until then, yeah, pretty much count on working with radians. But if I don't say anything, then, yeah, you're free to give me degrees. Yeah. So yeah, so your assignment that you got today is taking the place of your test.
Well,
so
yeah,
it's good.
I know about that.
Yeah.
Like for the unit circle cheat sheet that we get, like.
So on the first test of the semester, what would normally be the second test, I'll give you a blank unit circle, and you can fill that out, and then we'll use that for the remaining 3 tests. So the 2 tests in the final. Yeah. Haven't figured that out yet. Probably around 40. So, I mean, doing well on it certainly helps you out, but it'll make a pretty big difference. If you do poorly on it, it'll hurt you. If you do really well on it, it'll help you. So I would. Now, if you take a look at what happens, because if I do 40 points for this, then it'll be 40 points plus 2 tests is 240 plus 120 for the final is 360 points. If you got a 0 on that, that would really kill you. So now you're looking at the most you could get is 320 divided by 360. So the most you could get is like a B plus if you bomb this. But if you do really well, it's going to pull you up. So I'd suggest you do really well. Problem 42. Sine of theta equals the square root of 2 over 2. Wow, feels like this one's getting easier, right? I mean, hey, we already got this solved for pretty much. But there's a little catch. They want all the solutions. And let's take a look at the actual instructions there. It says, solve each equation, give a general formula for all the solutions. List 6 solutions. So, well, let's see what they mean here. Sine of theta is root 2 over 2. How else could I write that? In stereo. That was great. Too bad my home audience couldn't hear that. So, inverse, thank you, ladies. Inverse sine of root 2 over 2 is theta. So, great. We're looking for the angles whose sine is root 2 over 2. So let's look back at our unit circle. What angles have a sine or y-coordinate of root 2 over 2? Good. 45 and 135. Or in radians, pi over 4 and 3 pi over 4. So let's start there. So theta equals pi over 4, or theta equals 3 pi over 4. And that's a good start, but that's assuming that I just limit myself to between, say, 0 and 2 pi. What if I had pi over 4 plus another 2 pi? Or in degrees, it'd be like 45 degrees plus 360. So it'd be 405 degrees. Or 765 degrees, etc. I can keep on adding multiples of the unit circle here, right? I can do the same thing here, except that a multiple of the unit circle in radians isn't 360 degrees. What is it? 2 pi times n. Now, n is going to be an integer. It's going to be a 0, a 1, a 2, or a 3, or a negative 1, or a negative 2, or a negative 3. But really, what you're doing is you're adding on multiples of 2 pi. 2 pi times n. So these are the general solutions. That's the most general solution you can have, is right here. So that's our general solution. Because that's everything. It's not only the pi over 4, but it's all the coterminal angles that you can get with pi over 4. And likewise with 3 pi over 4. So that's everything. Now, they want you to list 6 particular solutions. Question before that? And really what they're asking for when they ask you for those list 6 solutions, they want you to put in some values for n. N equals 0, n equals 1, n equals 2, that kind of thing. So that's all they're looking for. Let's see if we can't do that. So I'll make myself a little bit of a chart here. And it's going to look like this. N theta is pi over 4 plus 2 pi times n, and 3 pi over 4 plus 2 pi times n. And let's plug in some different values of theta. If n is 0, well, that's pretty easy, right? This term will disappear. We'll get pi over 4. And this will be 3 pi over 4. All right, so that's 2 solutions. What about if n equals 1? If n equals 1, I get pi over 4 plus 2 pi. And I'm thinking that that's not what the book is looking for a final answer. So let me rewrite 2 pi. I'm going to write it as 8 pi over 4. Can anyone see why I wrote it as 8 pi over 4? Yeah, I got a common denominator. These two are equivalent. So pi over 4 plus 8 pi over 4 gives me 9 pi over 4. And at 2 pi over 4, if I put in a 2 here, it's going to be pi over 4 plus what? 2 times this is 4 pi. Good. This time it's going to be pi over 4 plus what over 4? Yes, 16 pi over 4 for a total of 17 pi over 4. So I've got 1, 2, 3, 4 solutions. I need 2 more. I'd probably go over to this column. And you can keep going with this. You can do 3, 4, 5, whatever you want. Just list 6 solutions. These are probably the 6 that you would see on my answer key. Pi over 4 plus 2 pi, or excuse me, 3 pi over 4 plus 2 pi. And I'll rewrite that as 3 pi over 4 plus 8 pi over 4, which is 11 pi over 4. And last but not least, 3 pi over 4 plus 4 pi would be 3 pi over 4 plus what? 16 pi over 4. 16 divided by 4 is 4. So these two are equivalent, but this one is written so I have a common denominator. I end up with 19 pi over 4. Yay. And you can go on and on and on, but I think you kind of get the general idea here. Let me kind of confirm this with Desmos. And the nice thing about Desmos is that it'll actually solve some of this stuff for you in a certain sense. So let's get rid of that, our little cardioid, and look at y equals the sine of theta. Looks like this. And then I'm going to try and find the points of intersection with the graph of y equals the square root of 2 over 2. Over 2. There you go. And you can see some of our points of intersection. Pi over 4, 3 pi over 4, negative 5 pi over 4, 7 pi over 4. But some of the other ones we got, 9 pi over 4, 11 pi over 4, 17, 19, etc. So all those points are there. And there's an infinite number because that line extends forever in either direction. All right. I suppose you're telling me it's time to go. I get the hint. So let's at least get started on the homework. Try 13 through 53 in the homework. Odds. 13 through 53 odds. Only if you want the extra credit. All right. Have a good one. See ya. Oh, yeah, I got to give you